Okay, so this is a follow-up to the first association video. Part B is always going to be the same. Again, it's practically free marks. Okay, so they're going to give you a table of the sort always. So you're going to have the sum of x data, which is in notation just like sum of x, sum of y data. And you got sum of the squares of x data, so x squared, sum of squares of y data, y squared, sum of the product of x and y data. Okay, so this is sum of x and y. Okay, so in this question we're gonna have to calculate the least squares line of y on x. If you think about it, this is basically the same as saying calculating the OLS line of y on x. So we're gonna get something of the form y is equal to beta naught plus beta 1 xi. Okay, if you scroll down to the bottom, or I mean not scroll down, if you go flip to the last page of your answer sheet, you're gonna have these formulas. Basically, let's write them down. Beta 1 hat is sxy divided by sxx. Sorry about that. Okay, and beta naught hat is y bar minus beta 1 hat x bar. Okay, this is all preliminary information, things you were going to be doing, but your first step, again, just memorize this. Your first step is going to be to calculate the sxx, the sxy and the syy, because using these things we can calculate this stuff. Okay, so the sxx is always going to be your sum of x squared minus your sum of x whole squared divided by n. You need to memorize this formula. So just applying it to our question, it's going to be 2033 minus 127 squared divided by n is over here, random sample of 10 employees divided by 10. That's going to give you, when you use the calculator, you're gonna get 420.1. Okay, now let's calculate the sxy. Okay, actually let's do the syy. Now the syy is just going to be y squared minus y whole squared divided by n. So you can plug in the values. It's just going to be 33662 minus 562 whole squared divided by n, and you can calculate that. But in this question you usually don't need to calculate syy, because to find our estimate for beta 1 we just need sxy and sxx. So I just want to show you how to just simply, I guess, sxy, the formula for sxy is going to be just the summation of x and y minus the summation of x into the summation of y divided by n. Let's see what this is going to be in our example. So the sum of products of x and y is 6402 minus sum of x we know is 127, sum of y we know is 562 over here, whole divided by 10. When you calculate that out, it's going to be minus 735.2. Okay, so we got SXY, SSX. We can use our beta 1 hat formula to now calculate our beta 1 hat. So it's just minus 735.4 divided by 420.1, and we get minus 1.751. Now let's look at the next formula. The next formula, we need to figure out beta naught, right, to get the line of least, because we got this. Now we need to figure this out. Beta naught hat is y bar minus beta 1 hat x bar. We know what beta 1 hat is. We need to know what y bar and x bar is. So y bar is the average y. So it's going to be just the summation divided by n, right? So we know the summation is 562 divided by 10 is going to give us 56.2. X bar we know is 127. 10 is going to be over 12.7. Let's plug it all in. -6.2 minus. Be very careful. You don't wanna get your algebra wrong. So when you plug it in, put the brackets. We got another minus here, so minus 1.751 into 12.7. That's going to give us around 78.4. Okay, so there you go. We got our line of least squares, 78.4 minus, let's put it beta 1 in, sorry, plus minus 1.751 xi, but let's simplify it. It's going to be plus, because minus into minus 1.751 xi. There we go. Okay. Actually, remember to draw the hat here, because it's going to be the predicted value. Okay, that's the first question solved. Second question is, based on the regression equation in part 1, what level of performance would you predict for an employee who scored 4 in the training? Very simple. Just plug in 4 for x. So your predicted y high hat is going to be 78.4 plus 1.751 into 4. It's going to give you 71.429. That's your answer. So you write it down. You say 71 hours is the predicted value for an employee who scored 4 in the training. Last one. It's going to be stock information. What additional, stock answer, like every single question you're going to use this. What additional information would you need to decide whether your prediction is reliable? Okay, every single time you're going to say range of x data, so that we can decide or assess whether the prediction is interpolation or extrapolation. Basically, the idea is, say you have data on people from ages 20 to 50 to predict their income. And you get a regression from this. I don't know, 60 plus 7x. Any prediction you make for someone who is aged like 10 or aged like 70 is going to be extrapolation, because you haven't, you only covered ages 20 to 50. So it's kind of considered to be less reliable or unreliable. But if it's anyone like 25 or 40, since they're within your range of x data, it's going to be interpolation, which is considered reliable. So yep, that's basically it. In every question, just remember the formula for SXX and the formula for SXY. You can calculate the OLS line. The second part is going to have you plug in an x and solve for it. It's very simple. In the last part, you're going to say range of x data to know whether it's interpolation or extrapolation every single time. So yeah.